I work at iCheck, looking at it from the perspective of how do our users at the end of the day and their workflows and applications and the services that we run for them have an impact on the design of our software infrastructure and also our data and our hardware infrastructure, but even broader, our data center and hosting infrastructure. So I might actually go a bit broad, and you might find this to be a more open-ended raising of a few aspects that are connected at the end of the day, driven by workflows and services. But I suppose the breakout and discussions provide the opportunity for us to tie things together. That's why it was more open-ended rather than giving a more, conclusive narrative here. So the context I'd like to maybe for us to consider for the next 10, 15 minutes is I'm going to ask you to maybe switch sides, look at it from not a workflow developer or user perspective, but also start looking at it from a how would an infrastructure have to work to facilitate or cater to the workflow characteristics that you're looking at. And I raise a few points to give you more visibility. I think there were already mentions on the software infrastructures for workflow managers, on scheduling mechanisms, and some indications towards Slurm-based or containerization, cloud-based management of the resources, and also CI/CD pipelines, etc. So pushing further, looking also at the hardware side. So where we come from is we are right at the middle of a procurement cycle. We are moving away from a purely batch system-based infrastructure, and we had tendency of our infrastructure. So we had separate infrastructures to cater to more cloud-like services. We are in the middle of procurement, so the requirement specification is ongoing now. So we don't have a solution, but what I'm going to raise is start from there. We're moving from the left. We did have a multi-petabyte storage infrastructure to cater to the data services. We had a Slurm-based traditional HPC infrastructure, which catered to the more traditional HPC community in Ireland. And our storage infrastructure served multiple purposes. It was used by our traditional HPC users as well, the numerical weather prediction, the climate simulation modeling community, but also the climate data was being used for public sector's policy making. So in a way, land use mapping needed the geospatial data to work alongside climate data, and they are not the usage model is not exactly the same from people that are doing climate projections or historical simulations and corrections versus people that use geospatial data for land use map generation and analysis. They are entirely different usage models of the same data and the same infrastructure. So we had siloed infrastructure catering to those use cases, and it was a nightmare. From the community perspective, it was easier, but from the manager's perspective of the infrastructure, it was a nightmare. What we are doing is not centralizing, it's more consolidation of our infrastructure from multiple sites, multiple hardware infrastructures, multiple software infrastructures as well. It's not a monolithic because it would be a honeypot for security reasons, and maybe a meteor shower might hit one site and everything will be gone. So we're looking at a more data-centric approach. So on one hand, it'll be a multi-tiered, multi-site data infrastructure, which is defined by actually the data characteristics and the usage characteristics of the data, but the compute around that has to be modular as well. So the modularity of the compute is no new design pattern, but making it data-centric as well, because modularity could be in multiple dimensions. You could consider the storage nodes as one module, but that does not necessarily, I'll come to that in a moment, serve different requirements from usage perspective. So we are moving to the more, data-centric platform perspective. And the new platform, Caspier, that is under procurement and provisioning would need to cater to migrating our existing services and infrastructure into that platform. So we run an EO data cube for the public sector research community as well. We do the climate, the EC Earth simulations and the CMIP data for our Met agency, and we are responsible or tasked with hosting and serving it persistently as well. So we have a kind of a subset of the ESGF node, which we need to kind of fully implement in a fully functional. There's also a need to kind of look a bit forward into the Caspier node not functioning just as a separate node. It would need to function in a federation, in the national context, predominantly in the data ecosystem, because data comes from different providers and they want to be able to use our HPC infrastructure, but also some of the data that we repositories along with data that they provide in terms of data linking and coupled modeling as well, and also contribute the Caspian infrastructure to things like the European weather cloud that's kind of forthcoming, so that it needs to be an interoperability or portability at least, all of that. And like I said, there are a bunch of data services that we run. So this is not what HPC centers typically do. HPC centers primary role is to provide compute resources, and data is a means by which it satisfies either the input or manages the output from the compute workload, even in AI. But then we run standalone data services. So the prime candidate there is the data, and then the value add is the processing around it. So they're kind of orthogonal orthogonal requirements from an infrastructure requirements perspective. And like I said, our users are not just academic researchers, they come from public services. So the city council, for example, wants to run a persistent digital twin service on our infrastructure purely for the reasons of not that they can go for a cloud-based or a public cloud-based solution. It's because they need some sensitive data to be managed. We have the climate data that we repository, geospatial data as well. So it's driven by the sources of data that service needs at the end of the day. And the last one, the Climate Plus Core Center is cross-jurisdictional. It's between the Republic of Ireland, Northern Ireland, and the UK. So there's a huge repercussion on not being able to centralize data, but also the accessibility of data across jurisdictions as well. So there might be a national license or legislation that supports national users, but then what happens when a model needs to be co-run by a few different parties across the three jurisdictions as well. So I'll touch on all of that in a moment. But I think the case was already made in terms of use cases, so I'll keep the use cases quite short. So I'll use this as an example to just illustrate purely from, if we look at it from a services perspective of using the infrastructure, then running an EO data cube, there is a backend stream of workflows, and then there is a kind of front-end stream of workflows. The backend stream is to continuously aggregate data into the infrastructure itself. So as new data becomes available from observational data, we need to kind of ingest or actually periodically run workflows that keeps adding newer data sets. And that in some cases can be computationally intensive tasks as well, because you're kind of tiling and stacking temporal cubes that you need to ingest into the data cube itself for use cases. So that's one thing that are also HPC intensive workflows that need to be automated and run in the backend. And then there is the front-facing one when data is served to a certain use case or an application, then the type of application itself needs kind of different forms of software infrastructure being available or software environments. So on the top right, we're probably looking at the more computationally intensive, machine learning driven or analysis driven use of the data cube or the data in the data cube itself. And at the bottom right, you're probably looking at when, for example, some of the data served in the analytics generates maps, then you're repositorizing the maps, or a researcher generates the maps, you're repositorizing it, but then you need to offer them as persistent results available through a notebook that's running for civil servants to jump into that environment, be able to spin up a virtual machine just to load that map and play around with it. And what playing around there is also dynamic. They may play around with just a static map which has some interactivity, but then it might be a more dynamic map where they're asking for a region which for which the map is not generated. So they might be actually spinning off new compute workflows as a part of that, or analysis workflows as a part of that. So the bottom right might actually trigger a compute workload itself. So that's one scenario. And then I'll just say the GeoCube is kind of a larger subset of an EO data cube. And what we're looking at is pulling data from multiple providers, which are not necessarily geospatial data. So then what are you doing about co-locating? Are you pulling in multiple petabytes or multiple terabytes from other sites on the fly? The decision is, how do you work with your NREN to kind of co-locate or provide infrastructure requirements to support that workflow? In many cases, I mean, at least in a few years ago, Netherlands made a good decision of unifying your organizations between NREN and HPC. That's not the case with Ireland. You need to have two different organizations talk about how your infrastructure planning and implementation aligns. So long story short, the kind of use cases and their workflows on the first layer have an implication on the bottommost layer, which is how the data are provisioned into a compute or analysis environment in memory, for example, both from the on-prem data nodes, but also from other data infrastructures within Ireland, or even from the Copernicus data space, for example, in some cases. And then the type of computational requirements are not always HPC intensive on HPC infrastructure going forward. For example, your catalog services, your metadata services, your data ingestion services, they can run on any server that's sitting on a desktop on someone's lab. But you need a certain, I mean, technically speaking, we still haven't killed that elephant, I'd call it, not dinosaur yet. We still have a community that says like, okay, I can still run it from my own server. Why would I need to come to iCheck as a HPC provider? The perception is HPC is not large-scale multi-node distributed memory execution. SLAs and time to solution and efficiency is also a critical part of HPC. For catalog servers, you need high SLAs. It's not compute intensive at all. But typically, in some cases, we have to consider, do we want to run catalog servers on a VM on one of our cloud partitions, or do we want to run it for easier purposes on Cloudflare, for example? It's just one component within our service, which may run on multiple infrastructures. That's a decision that we need to make as an organization. It has different positives and negatives. How do we charge our EPA for using our services? Creating a cost model is more difficult, is already difficult within one infrastructure. If we have multiple infrastructures providing multiple services or multiple resources for multiple components of a service, then building up a cost model is going to be even more difficult. So it has implications. Again, an open question, not solved yet. I don't mean to walk through this, but this is the ESA validation data center. So what this does is basically the EVDC provides the CalVal service, and we run it for ESA. Broadly speaking, what happens is on the top left, you're ingesting satellite data, Sentinel, EarthCare, AOLS data from multiple sources. We ingest that into our S3 storage on our site. That's the top part, and then we ingest it into an open searchable catalog as well. And then in the middle part, we get ground truth data from NILU. And then naturally on the bottom part, what we allow for is the end user, the scientist, basically. We have a repository of validated containers, which can be composed with CWL for kind of these CalVal workflows, different types of workflows, but we also allow for users to bring their own containers or Dockers, basically, for components of the workflow. So on the fly, we need to make sure that, or that needs to be an automated, but also a manual process whereby container security need to be ensured when they're being plugged into a CWL workflow on the fly. And then the orange bit is the computationally intensive part. When a workflow is there, then how do you schedule it, run it on a series of workhorses on the HPC infrastructure, for example. So you might actually see that the top part again is kind of a batchable, periodic workflow, and then the bottom part is more dynamic. And at the end of the day, as an infrastructure provider, we need to cater to both characteristics within the same service. On one hand, that's easier. This is working alongside your traditional HPC users. And then you have something like an EOCube, an EVDC, all trying to run on the same infrastructure as a whole. How do you manage the SLA quality required for all services? Because you sign up different agreements, they don't care about you're running same on the same infrastructure or different infrastructures. And last, and I will skip these are more research driven. This is a telecommunication testbed whereby in universities, they run different telecommunication units, they do experiments, and then they're ingesting or streaming their data from their experiments with a Kafka client into our project, into a project we provide for them, because they want to do machine learning and training on that. So they want to kind of have almost like a streaming environment. This is an ask of the new infrastructure. This is not currently available. And then I'll just use this example to highlight a semi-automated sensitive data management. So this is For the Health Research Board, which is our agency for health research in Ireland, we built a prototype or a pilot of, we use entirely synthetic data, so that made the life easier. But then it was basically the infrastructure called Dazzle for secondary use of health data in Ireland. That is now feeding into the Irish implementation of our health data space for secondary use. The important thing here is the safe haven in the middle is where you would typically have a virtual data room where you spin it up just for the purpose of the research that is approved. A data controller works with a third party to anonymize or pseudonymize and link the requested data for that study, place it in the virtual data room. We need to ensure that from an infrastructure perspective, the infrastructure can be sliced out right from the processor or silicon through to software, through to the application from a shared infrastructure, a multi-tenancy infrastructure, and then so certification is the easy part, but then ensure that the project is wiped out at the end of the project's approval and so on. So that places both infrastructural requirements, but on the bottom right, it places an organizational requirement as well, because governance is just not on data. Governance is what are we involved in when we sign up to DPIAs. Do we sign up DPIA per data set? That's a nightmare for the legal department. So that places institutional requirements as well. Long story short, I probably have 2 minutes to finish. How we go about capturing the requirements is we need to take it at a use case level, group use cases to capture what data characteristics do those use cases bring or ask of the infrastructure. So this is the first level where we try to assess what are the data characteristics in terms of not just their size, but their rate of growth, their ingestion, their performance requirements. What kind of data formats are we looking at? Because we run the Copernicus C3S Glamour services. Typically, we ingest tens of millions of files for every batch, CSVs. And CSVs and lusters don't like each other. And that's the norm currently implemented. So the users at the end of the day spin up a job to run a Glamour use case service. The job runs for 2 days. What's the utilization characteristic there? Is that valid? When we looked at it, it was because CSVs and lusters don't like each other. So we are actually implementing in the platform, in the software infrastructure, a translation between a CSV and a GeoParquet format. And GeoParquet, that's not easy because you're just transferring the complexity into the processing part, because the workflow and GeoParquet don't like each other. So you actually have to refactor the implementation to work better on the GeoParquet. So this is not up to the user at the end of the day. Okay, the user, you can say, make your workflow perform better for GeoParquet. But then we have to consider as infrastructures provider. So it's just not providing hardware. We need to look at the software infrastructure toolbox as well. So these kind of data characteristics have an implication on how are we implementing the software infrastructure for services. And then compute characteristics, they're easier, probably, relatively speaking. And then usage characteristics, what kind of usage model, command line or GUI or different as services, their fancy names, implications on horizontal and vertical scaling, auto scaling as well. Do we need to have other resources in addition to our on-prem resources where we can scale, explode, and they then feed into different hardware, data center, even caging, virtual caging, physical caging requirements as well, because we might want to co-locate our cancer genomics data because they want to use solar irradiation data for skin cancer analysis. They typically reside in 2 separate silos, but agencies want to work with each other. So the use case has to be facilitated by the infrastructure. We cannot say, bring your cancer genomics data into your climate solar irradiation data resource or infrastructure. We cannot say, bring your climate data into your Dazzle infrastructure. So how does that work in practice? That's an ongoing conversation. The data governance and across both parties have to be interoperable, and then infrastructure interoperability is the easier bit. And that kind of brings me to the last thing. I would like to stop at this. The technical infrastructure is what I've been talking about, the bottom right. That's the easiest bit in this triangle. The left bit is probably the second or second more difficult. It's like sectoral or thematic requirements in terms of data formats, performance, service SLAs, and so on. The most important thing that we are having to solve is data governance. and institutional governance. So I leave with that. And yeah, this is something, a national implementation of common data spaces for an Irish perspective, because we say Ireland is small enough, but large enough for us to have a multifaceted problem being addressed. So I leave it at that.